What if I told you that the past, the present, and the future aren't sequential? That they all exist at the very same time? I mean, that your entire life, from the day you were born to your very last breath, is already laid out? It sounds like something straight out of science fiction, right? Well, modern physics suggests this might actually be the true nature of reality. So that brings us to the big question for today. Do your past, present, and future all exist right this very second? Are you, somehow, a baby, the person watching this, and on your deathbed all at once? I know, it sounds completely bizarre, but according to physics, the answer could very well be yes. So let's unpack how that's even possible. All right, to get our heads around this, we first have to face a hard truth about our own perception of time. You see, the way we feel it pass, day by day, is fundamentally different from what the laws of physics tell us is actually happening. We usually think of time kind of like a movie reel, you know? Each moment is a new frame. The past has already played, it's gone forever. And the future, that's just a bunch of blank frames, not yet written. In this view, the only thing that's actually real is the present moment, our now. It's a super intuitive idea, but it's not the full picture. And here's the crucial point, the real mind bender. Our gut feeling tells us time is like a river, always flowing forward. But physics, it suggests it's more like a frozen crystal, where everything is already fixed in place. The fundamental laws of the universe, the things that govern everything, they don't have a special now or a direction of time built into them. To understand why, we have to stop thinking about time as its own separate. And this is where the one and only Albert Einstein enters the picture. His theories of relativity completely changed the game by fusing time and space into one single concept, what we now call spacetime. So Einstein showed us that time isn't universal. It's not this one constant clock ticking away for everybody. Instead, it's woven together with the 3 dimensions of space into this 4-dimensional fabric called spacetime. And the key takeaway from that? Time is relative. It can actually stretch and shrink depending on how fast you're moving. An astronaut whizzing around in orbit literally ages slower than we do down here on Earth. Our GPS satellites even have to correct for this every single day just to work properly. This is proof that there's no single universal clock for everyone. Now, if time is relative, it leads to this absolutely staggering conclusion known as the block universe theory. This model views all of space-time as a static, 4-dimensional block that contains every single moment that has ever been or ever will be. The core idea is that the past, present, and future are all equally real and they exist simultaneously. Time doesn't flow, we just experience our personal journey through this pre-existing block. This brings us to what's called the problem of now. Because if this block universe theory is correct, then our whole concept of a shared present moment, it just completely falls apart. Your now is simply not the same as anyone else's. What you call now is just your own unique slice of the space-time block. But someone moving relative to you, they're experiencing a completely different slice, a different now. And this isn't just some wacky thought experiment, it is a direct consequence of Einstein's laws of relativity. Let's use a thought experiment to really see how this works. Imagine there's a stationary alien ship far away. It shares your now, simple enough. But what if another ship starts moving away from you? Well, its slice of space-time actually tilts. Its now could be simultaneous with your past, say the year 1924. And if a third ship moves towards you, its now could line up with your future, maybe the year 2124. So which now is the real one? Is it yours? The aliens in 1924? The one in 2124? Well, relativity tells us there's no single right answer. This is the principle of cosmic democracy. Every perspective is equally valid. And think about it. If their now can be our past and our future, it means our past and future must be just as real as our present. They have to all exist at the same time. Okay, so if the past, present, and future all coexist, we have to ask the next logical question. Is the universe already written? This has some really profound and honestly pretty unsettling implications, especially when it comes to the idea of free will. This is the formal definition of that block universe theory we were talking about. So think of the universe not as a story that's being written, but as a book that's already finished. Every page, every single event, from the Big Bang to the very end of time, is already there. It's a static, unchanging block, and some people even describe it as a frozen block of cosmic ice. And this, of course, leads to the really big question, the one that keeps philosophers and physicists up at night. If everything that will ever happen is already set in stone inside this block, does that mean our choices are meaningless? Is free will just a powerful illusion our brain creates? The physics community is pretty divided on this one. One perspective argues that, yeah, your path is set, but your choices are still real. They're just part of the block's pre-existing structure. You are always going to make that choice. But the other view is way more deterministic. It says everything was set in motion from the very beginning, and that feeling of choice you have is just an illusion. But just when things seem completely locked down and deterministic, physics throws us a massive curveball. There's this whole other field that seems to contradict this frozen block idea, and that's quantum mechanics. And it might just be the one thing that saves the future from being written. See, unlike Einstein's relativity, which is deterministic, quantum physics is all about probability and true fundamental randomness. For example, we can calculate the probability that a radioactive atom will decay in the next hour, but it is impossible, even in principle, to know for sure when it will happen. And this isn't because we don't have good enough tools. It's a fundamental feature of how reality works at the smallest scales. This quantum randomness gives rise to a totally different model. Instead of a static, frozen block, maybe we live in a growing block universe. In this view, the past is fixed and real, sure, but the future is genuinely open, a sea of possibilities. The present moment is the very edge of this growing block, where all those uncertain quantum events finally become certain, crystallizing reality as time moves forward. So we're left with this incredible tension in modern physics. On one hand, Einstein's famous words here seem to hold true. Relativity strongly suggests our experience of time's flow is nothing more than an illusion. But on the other hand, quantum mechanics pops up and says the future can't possibly be set in stone. And that leaves us with the ultimate question. Is reality a frozen block where the future already exists? Or is it a growing block, being written moment by moment through pure quantum chance? The honest answer is, we don't know yet. But what we do know is that the simple, linear time we experience in our daily lives is almost certainly not the full picture. The real mystery might not be how time works in the universe, but why our minds perceive it the way they do.